All right, so we're here doing 8.3 from the homework. We're starting here. Basically, just use the calculator to find each measure to the nearest degree. I started off doing them just to make sure I could use the scientific calculator okay, and I double-checked that it was on degrees. So we did tan -1. I'll do the rest here, but that was over here. We're talking about nearest degree, so that is 65 degrees. Right here, let's actually use that one, equals 65 degrees. Let's make that a little nicer. Cosine negative, the inverse cosine of 1/3 looks like 71 degrees. And then inverse cosine of 5/6 is 34 degrees. All those happen to be rounded up. So how am I going to enter these in, basically, is, that doesn't really look like a 4. So let's try that again. Just for fun here. All right, so 34 degrees. All right, pen's a little crazy here. All right, anyway, so as far as the, I don't know what's happening. Okay, anyway, doesn't matter. So we can plug these in. Basically, we're going to use the inverse sign. Sometimes that second sign, it probably will be on your calculator. In this case, the one that I'm using online, it has a button right here in the function. So sine -1, and then we put in 0.5, and we hit it, and it's 30. So this one is exactly 30. Okay, 30 degrees. Sine -1, so we'll do that. Sine -1 of 0.61. So we plug it, that's a comma, 0.61, and we'll close it up. And we get 38 degrees. It looks like it also rounds up. Okay, tan -1.009. So tan -1.00, 0.09. All right, and looks like 5 degrees. All right, sounds good. All right, so if we go down here, find the unknown measures, so round the lengths to the nearest hundredth and the measure angles to the nearest degree. Okay, so in this case, we have two sides. Again, we can find the missing third side here using Pythagorean Theorem. Again, that's not too new here, so I'll just put C for the side we're trying to find, X for this angle, Y for this angle, and we can write some equations. All right, so first step is, of course, we do know that 3.1 squared plus 8.9 squared equals C squared. Okay, and we can solve that. Let's see if I can do this. 3.1 squared, and then we got plus 8.9 squared. All right, good. And then we can say, you know what, let's take the square root of that. Does that work if I somehow do that? I don't know. See if I can paste it in there. Yeah, looks like we get, so C is about, again, round to the nearest hundredth, so that's 9.42. So C equals 9.42. And again, that is 42. All right, and then nearest degree. So that's where we need to write some equations here, because basically, we can find one and then subtract from 90 to find the other, or we can find them, we can write them both these equations. So if I do that, we end up with, let me move this up a little bit. All right. We end up with, if I want to find x, well, again, we have opposite and adjacent, so that's tan. So we can basically think, all right, well, the tan of x equals the opposite, which is 8.9 over 3.1. It's being weird here, but that's okay, 3.1. And so we know that x is going to be the inverse tan of 8.9 over 3.1. Okay, and we can plug that into the calculator to get the angle measure here. So this is a weird one. Sorry, guys. Okay. I lied. Inverse tan. Stop it. Stop it. All right, inverse. No. All right, inverse. All right, I'm not angry. I'm just disappointed. All right, 8.9 divided by 3.1 and close it up. And so we get 70, looks like what, 71 degrees. So that's 71 degrees. Again, once you know one of them, you could either write another equation like this, or we could just subtract from 90 and we can get 19 degrees. right? So 71, x and y is 19. So I'm just going to label each one kind of in that same way. Okay, so we get actually, this one's a little different because we actually have two sides. We actually need to find the legs. We need to find A and B here, which usually are the legs of a right triangle. And I'm going to call this angle X. So to find the angle is not so bad. We can actually find that one first. That's just we subtract and get 58 degrees. And then now we need to use trig to find one of the sides, right? So if we can do that, we end up with, let's find basically, let's use the 32-degree angle because it's right there. So we're trying to find the opposite, and we have the hypotenuse, that's sine. So we're like, okay, well, sine of 32 degrees equals the opposite, A over the hypotenuse, 7.4. And so A is just going to be 7.4 times sine 32. And so A is just going to be equal, and I'll plug that in. I'm going to write the other equation right now while I'm at it. And so the other equation would be, all right, we need to find the adjacent over the hypotenuse. So that's just cosine. So the cosine of 32 is going to be the adjacent, which is B over the hypotenuse, 7.4. So yeah, B is just going to be 7.4 times cosine 32. And again, we can get B here as well. So let me plug that in. I don't like why it's writing weird, but you know what? That's fine. All right, so we get 7.4 sine 32. And we have 7.4 cosine 32. Okay, so our values for A is 3.92. Where are we? Where? There we go. 3.92. And then 6.28 for this one. All right, this one is very similar to the first one. We're trying to find the hypotenuse. We want to find each of these angles, so I'll call those x and y, hypotenuse C. So C we can find using Pythagorean Theorem. We know that 8.6 squared plus 11 squared equals C squared. So once we plug all that in, we can say, all right, 8.6 squared plus 11 squared. All right, and we can then take the square root of that whole thing, actually. Maybe. I can do it in one step, and we get 13.97 for C. So C equals 13.97. All right, if I want to set up one of these equations, we're going to start with x, opposite and adjacent. That's tangent. So we know that tan of some angle equals 8.6 over 11. And so we can use the inverse tan of that ratio to get that. And so our angle for x is just going to be, and we're going to round this thing, but let's see, we got inverse tan of 8.6 over 11. And that's 38.01, so that's 38 degrees. So if we have 38 degrees, that must make y 52 degrees because they're complementary. All right. This is more just plugging into the calculator, and yeah, they're more pretty much the same. But we can I'll plug these in the calculator. We'll go before pausing, before going on to the next page. Let's see if I can get this sorted out. All right, so we have sine, inverse sine of 0.31. We have, I'm just going to do all these at once, inverse tan of 1. We have inverse cosine of 0.8. We have inverse cosine of 0.72. So these are just a matter of plugging them in the right order. And we have inverse tan of 1.55. And we have the inverse sine, finally, of 9 over 17. All right, so we start up here, 0.3. So we can just round to the nearest degree. So we have 18 degrees. We have 45 degrees. That makes sense. We have 37 degrees. Rounded that one. Cosine 0.72, 44.0 degrees. So 44 degrees. Oops. Degrees. And then we have 57 degrees. And then we have 32 degrees. Okay, not so bad. Those are just plugging us in. We might as well just keep on going. Okay, so we keep on going here. We end up setting up, I'll set up all the equations first, then I'll do all the calculations for all of these. So we can look at this leg, and this angle. And of course, we can find x is just going to be 64 degrees because those two are complementary. All right. And then we can write an equation to find a, and we can say, all right, well, a is going to be the adjacent side to this, or it's the opposite side of this 26. So opposite over hypotenuse, that's sine. So we can do sine of 26 equals the opposite, a, over 3.2. And so, yeah, we get a equals 3.2 times sine 26. All right, so that's what a equals. And then b is just going to be, well, b is going to be adjacent over the hypotenuse. So we can do cosine of 26 equals the adjacent over the hypotenuse. So yeah, b is just going to be 3.2 times cosine 26. And that's what b is going to be. So we'll get those answers now. We'll have 3.2 sine 26, bam, and we have 3.2 cosine 26, and we get 1. Wait, for a is 1.40, and for b we get 2.88. All right, next one. We do Pythagorean Theorem. We get I'll label our sides at C. We got our angles x and y we need to find. 3 parts we need to find. So we get radical 2 squared plus radical 5 squared equals c squared. So that's going to be 2 plus 5 is just 7 equals c squared. So yeah, radical 7 is c. Okay, then to find this, well, we can use the two sides that we know, and we can say, all right, we have opposite and adjacent. That's tan. So we can say, all right, the tan, we see the pattern here, hopefully, but the tan of an angle is going to be radical 2 over radical 5. And so we find the actual angle, it's the inverse tan of radical 2 over radical 5. And so let's get that value. Once we round that, then we can find the rounded version of y2. Okay, so we have the inverse tan of radical 2 over, radical 5. Radical 2 over radical 5 inverse tan. So it looks like 32 degrees. Right, so if that's 32 degrees, then that is 60 or 58 degrees. No, 58 degrees. Okay, awesome. Let's go on to this one over here. We're trying to find this angle x, this angle y, this side a, we'll call it. So we have a squared plus 6.7 squared equals 8.3 squared. And we can do most of that. We got 8.3 squared minus 6.7 squared, and we can take the square root of that whole, should not have done that. All right, so that's just 24. So it's just radical 24. All right, good to know there. So we get radical 24, which is just going to be 4 times 6, so 2 radical 6. So that's what a equals. Keeps on connecting them. Okay, then to find x, well, again, we have opposite and hypotenuse. I can actually use sine. So we know it's going to be sine of this angle is going to be the opposite, 6.7, over the hypotenuse, 8.3. And so we know x is the inverse sine of 6.7 over 8.3. And so we'll put that in. inverse sine of 6.7 over 8.3. Okay, and so that looks like 54 degrees. So where is it? So 54. And so y is going to be just 36 degrees. And those are rounded like it asked for the nearest hundredth. Okay. Deciding the triangle go below, find the measure of the acute angles in the triangle. Okay, so basically this is the same thing that we're doing up here. The only difference is that, I mean, we're basically finding the two angles. The only difference is that they didn't show us the triangle, so that's all we really have to do. We know the sides are 3, 4, and 5, so 3 and 4 have to be those. I'll just draw them all out while I'm at it. So we know that 13 is the hypotenuse, and then 5, 12. And then we have the 8, 15, 17. So we have 8, 15, and 17. Okay. And the idea here, we switch to green, is that we can just find these two angles, which are the two acute angles, x and y. We can find one. It says we're rounding anyway, so we'll find one and then subtract. We could also use the precision of each one of these to find them more exactly. But because we're rounding to the nearest whole degree, it probably won't matter. Okay, so because we have all the sides, we can sort of take our pick, right? So I can say, all right, let's just pick sine. So sine of x equals opposite 4 over hypotenuse 5. So x just is the inverse sine of 4/5. And I'll do both of these. Well, I'll just do that now. All right, so inverse sine of 4/5. 53 degrees. So x is 53 degrees. So y must be 37. And again, based on where I'm labeling them. All right, so we'll have x and y here. All right, so I'll just use cosine on this one because I can choose. So we have cosine. Again, I know it's going to be that the angle x is going to be cosine of the to the -1. So I just sort of skip that first setup. I maybe shouldn't, but 5 over the hypotenuse 13. And so we end up with, let's do this. Again, I'm just choosing one of each. You can sort of choose any of your trig functions. If you have all the sides, it doesn't really matter which one you choose. So we get 5 over 13, looks like 67 degrees. So we get 23 degrees. And for y, that is. Okay. And then finally, in this case, we'll use tan just because we can. All right, so we'll say that the angle x is going to be the inverse tan of the opposite 15 over the adjacent 8. So we know that angle x is going to be the inverse tan. Again, I just chose sine, cosine, tangent. I could have chosen any of them for any of them. Any of the trig functions for any of them, that is. And so that is 62 degrees. And so we end up with, 28 degrees here for the other angle. All right. And it says find each indicated measure. So there's only the one, but that's BDC. So BDC is this. It does say it's a rectangle, which means if this is 7, and then this is 7 over here. So we actually do, and we know that's a rectangle, that's a right angle. It's basically just putting one thing in the context. We're saying, all right, we need this angle. So from this angle, we have opposite and adjacent. That's tan. So we know that tan of this angle, which I guess I'll call x, is going to be the opposite over the adjacent. So x has to be the inverse tan of 2 over 7. And so x has to be, let's do that, inverse tan of 2 divided by 7. And it's about 16 degrees. All right, thanks for watching.